Our first distribution for a continuous random variable is a uniform distribution. Admittedly, it is unusual to find this distribution in nature. Most events simply do not have the same probabilities. We study this distribution mostly to reinforce the relationship between the area under a density function and the probability of an event. A uniform distribution is one where, as the name says, the probability of any value of the continuous random variable has the same probability of happening as any other value. The graphs of the uniform probability distribution are sometimes called rectangular distributions because they are rectangles when graphed. Here we see a graph of a uniform distribution where the letter A indicates the lowest possible value of the random variable, and B indicates the highest possible value. This is the full range of values of the random variable. The height of the vertical axis, marked f of x, is the probability of any and all values of the random variable in this range happening. Notice that the line of the distribution is a continuous line, meaning that all values are possible values of the random variable, even the smallest fraction of a number. When we graphed discrete random variables, we used boxes that indicated that we were looking at probabilities of specific individual whole number values. Mathematically, we write the formula for the uniform probability function as f of x equals 1 divided by b minus a. Probabilities are calculated by simply calculating the area between the desired values, multiplying the height, f of x, which is the probability of each value individually, times the width. For example, if we desired the probability between the values of x0 and x1, we simply subtract x0 from x1 to get the width and multiply times the height, f of x. This would be the probability that x fell between x0 and x1, as indicated by the mathematical statement, probability x0 equal to or less than x1 equal x1 minus x0 times f of x, and shows as a shaded area on the graph.